Good morning, everyone. My name is Mike Clark, and I would like to welcome you to today's DBA virtual chapter. Today, we'd like to welcome Matan Youngman. He will be presenting query progress tracking in SQL Server. It's going to be a very good presentation today. Always nice to know what SQL Server is doing and how, if we can track it. Those of us who are detailed and control freaks, and today's poll showed that 64% of those attending today are DBAs. So a good DBA is either a very well-developed control freak or a wannabe control freak. So being able to track things is very good. And today's session is being sponsored by Dell Software. We do appreciate Dell Software partnering with PASS organization to help fund these presentations. Technology is great, allows us to reach out to a broad audience at a modest price, but there is an overhead cost, and they help offset that. Thank you very much, Dell. Today, excuse me, SQL Pass is coming up here shortly. There's a little, we want you to be able to vote for the upcoming elections. So if you go to My Pass profile, you go to SQLpass.org and click on My Pass profile. There's instructions how to update that so you can actually vote, because your vote does count. We want to have everyone involved in electing leadership for SQL Pass. So go to SQLpass.org and update My Pass profile by the beginning of next month. So one of the things that Pass does is it's all about education and building the SQL Server community. One of the today is one of those sessions. There's other ones that go on throughout the year. One of the biggest ones that we do these days is SQL Saturdays, and it's pretty much just as it sounds. It's a Saturday full of SQL stuff, SQL Server. They are both domestic here in the U.S., North America, as well as international. In the next 2-3 weeks, looks like there's about 10 of those going on. Some in Iowa, Houston, Edinburgh, Sri Lanka. I think that's the first time we've had one in Sri Lanka. So if you're in the area, please go to SQLSaturday.com. There's agendas, there's ability to sign up. You get to meet a lot of local folks. It is a very good time, and a lot of good SQL learning going on as well. The ultimate SQL Server education and community event is called the PASS Summit. This year, the summit is be going on in the last week in October. They changed it this year. They moved it a week earlier. There is a discount going on right now until July 12th. If you enter this code here, the VC15FPS3S6, you get $150 off. And so if you do that, that's probably one of the best deals you can get at this point. So these slides are available at dba.sqlpass.org. It's a DBA section under the sqlpass.org homepage, and you'll be able to grab that code if you don't have it. But the discount does end next month. Other things that go on, other training that goes on with SQL Pass is there's many different virtual chapters. Today we're talking about database administration, but there's big data, there's Oracle, there's women in technology, there's architect, there's cloud, there's language-specific organizations as well. So if you go to SQLpass.org, you can get much more detail about all of those. And if you don't see something that you think is important, it would help and benefit the community, you can propose that particular virtual chapter and help get that off the ground and get that started, so you can be involved in a very grassroots way at SQL Pass. And I just will point out today there's actually a global Hebrew virtual chapter. I have not noticed that before. And as we mentioned on the previous page, you can help start a virtual chapter, but PASS is a volunteer-run organization. So if you have any desire or interest to be involved with anything to do with SQL Server at the local level, I'm actually remote from everybody else. I'm actually sitting in usually sunny California. Today it's kind of overcast. Our speaker today is from Israel. Most of you are all over the North American continent, or even around the world as well. So we can volunteer where we are at, and PASS needs a lot of good folks to help run all the things that they do. So if you are interested, again, I keep mentioning SQLpass.org as the starting point for all things SQL, and that would be a great thing to do. Other ways to be involved is you can join PASS, of course. It is free. There's LinkedIn, there's Facebook, there's Twitter, and anything else you can probably think of, you can probably start one if it's not there. But to today's topic, today's presenter is Matan Youngman, as we mentioned earlier. He's a senior consultant and professional manager at Madeira SQL Services. He's been working with SQL Server since 2002, which is a fairly long time. It's pretty good. And today he spends his time consulting, mentoring, and doing many things with SQL Server. He's involved in the community as well, doing SQL Server Radio, which I listen to quite often. Podcasts for SQL Server professional developers, and he is passionate about SQL Server. He's been a SQL. He's presented at many levels within the SQL Pass organization, and he's very passionate about the SQL Server community. And with that, I'd like to welcome Matan, and I'm going to make you presenter, sir.
Thank you, Mike. And can you see my screen? The first slide?
Trying to get there. Hold on. Yes, I do.
Great. So, hi everyone, and welcome to Query Progress Tracking in SQL Server. It's fun to be here. And I think it's a very important topic, and on the other end, it's a very, very tricky and mysterious topic, because I believe that basically every day all of us run queries, and for some of them we have no idea when they're going to finish. So I hope by the end of this presentation you'll have a few more tricks in your arsenal in order to know when those queries are going to finish. So basically Mike did all of the job. By the way, Mike, I'm glad to hear you listen to the podcast. It's a very, I believe it's a very fun way to learn about SQL Server and about technology when you drive into work or jogging or washing the dishes or whatever. So if that sounds fun, then give it a shot at sqlserverradio.com. And let's start. So let's get into the mood. It's Friday. You already have plans for the weekend. You want to take your wife or your kids to some kind of a pretty lake or a pretty mountain, or just want to hang out in the house. But for some reason, you decided it's a very good time to run one last script. And you forgot that Murphy is going across the halls on Friday, right? And when you run this script, it becomes a nightmare. Mike, I would like you to bring up the poll, and I want every one of you to say, has that ever happened to you?
Good. We have 60% of the folks
Mike,
have voted. Yep, 60% of the people have voted.
Mm-hmm.
So, okay, that seems good.
So we'll wait a few more seconds.
And here are the results. Can you see them?
Let's check. No, maybe
okay.
You were with us?
So, yeah, the poll results say yes, 80% of the folks have had that happen to them, and 20% have said no, not yet.
Okay, so I'm not sure about the 20%, guys. You may be lying, but okay. But 80% say it happened to them. I believe it's closer to 90 or 100. But anyway, for anyone who had this problem, let's say you decide, okay, it's a problem, but let's roll back and go home, right? So let's check. What I have here is just a plain alter index statement. We use the AdventureWorks 2012 database, and we will rebuild an index with a maximum of 4 threads, and we will run that. And from another session, we will start monitoring it And we will see, we see it's running. And from SysDM OS tasks, we can see we run with 4 threads. Oops. Take some time for my SQL Server to ignite, and we will give it a few more seconds. We can see we have 4 threads running. And after 30 seconds, we decided it was a mistake, and we stop it. And we think that it will just stop it, we can go home, right? So it's wrong, because for every single thing that SQL Server does, it has to roll back. And everything that we did here with 4 threads, SQL Server has to roll back, but the rollback is almost always, the vast majority of the process of the rollback is single-threaded. So everything that we did with 4 threads, we now do with a single thread. And this demo actually didn't work. Usually, it takes anywhere from 2 to 3 minutes to roll back the process. So please be careful when you roll back stuff. And to be fair, in the vast majority of systems and processes, the rollback will be very fast. But in some situations like this one, this can take a very long time, so you need to be careful. So let's talk about our agenda for today. We'll talk about our toolbox, the DMVs that will help us monitor our queries. We'll talk about the percent complete column. It's a column in SysDM exec requests that can help us monitor some of our processes. We will talk about index build tracking. We'll talk about identifying, executing batches and statements. And then we will talk about monitoring the progress of our queries. Okay, so DMVs, SysDM exec request. Every time we hit F5 and run a query, our query is translated into a request. And in this DMV, we can see all of our requests. And by crossing apply to SysDM exec SQL text, we can get the text of the statement and the batch. By cross apply to SysDM exec query plan, we can get the estimated execution plan of the batch and statement. And by using cross apply to SysDM exec text query plan, we can get the query plan of the specific statement. The difference between SysDM exec query plan and SysDM exec text query plan is that the first DMV returns the execution plan for the whole batch. And if you have a batch with, let's say, 30 statements, it can be quite frustrating to find the specific statement you want to monitor and troubleshoot. So we can use SysDM exec text query plan to get the plan of the specific statement. Now, the problem with SysDM exec request are that the values are for the parent thread only. If we run a statement that runs in parallel, we will see only one row for this statement. And for that, we can use SysDM OS tasks and OS waiting tasks in order to see all of the threads that are running and see why are they problematic. And starting SQL Server 2014, we have a very cool DMV that is called SysDM exec query profiles that allows us to monitor the progress of a query while it's running per operator, per thread. And we will see that later in the presentation. Okay, so we'll start with the percent complete column. As we said, it's a column in SysDM exec request, and it works when the amount of data is known in advance to SQL Server. And the supported operations are backup and restore database, alter index reorganize in DBCC index defrag, which basically do the same, DBCC check DB, check file group, and check table, DBCC shrink database file and auto shrink, recovery and rollback, and transparent database encryption. So it won't work for a query that is currently running. It will work for, let's say, if you perform a backup and you want to monitor the progress of this backup, it will work, and we will see a demo in a minute. Another thing we can do is monitor the build and rebuild of our indexes. For online index operations, in Profiler and Extend Events, we actually have specific events for this operation. In Profiler, it's called Progress Report Online Index Operations, and in Extend Events, it's called Progress Report Online Index Operations. So we can monitor that if we build our indexes online, and it works really, really well. For offline index operations, it's more tricky. We will have to monitor the amount of pages that were already processed by our process, and we will have to know in advance the size of the index in order to be smart and know when our index is going to finish rebuilding. And let's see a demo about it. So we will close that. And we will open backup and online index. And we will take this statement and run it from a new tab. And from this time, we will look at the percent complete column, and we can see it starting to go up, 20%, 20, 26, 27, and so on. And using the percent complete column and the estimated completion time column, we can guesstimate when it's going to finish. So we can see we have 7, 6, 5, 4, 3, 2, 1, and we're done. So it's pretty accurate and working pretty well. So for those supported operations, this can be a very handy tool, and we can use it wisely. Now let's talk about, and as we can see, these are the supported operations. Now let's open Profiler. And it will take a few seconds. And we will connect to my computer, which is called Schnitzel. I really like Schnitzel. And we will open our template and run it. And for a start, we will perform a single-threaded online index operation and run it. Oops. This is the right database, and when we run it, we can see it starting to go up, and we have two columns, the begin data 1 and the begin data 2. The begin data 1 column shows us the amount of rows that were already processed. You can see 70,000 and so on and so on and so on. And the second column is the thread number. As we can see, we have only thread number 0 because we build the index with only one thread. Now let's do that. We'll clear the profile trace, and we build that with 4 threads. And when we go to Profiler, we can see everything starts to go up. And we can see that we have 4 threads, and each and every thread handled almost the same amount of rows. So if we build our indexes online, it works pretty well. We can use either Profiler or more recommended to use Extended Events, and we can monitor our processes like that. For offline index operations, it's more tricky. So for a start, we will execute this statement, this query, that will show us the size of the index. And we can see that this specific index has 3,738 pages. And we will remember this information, and from a new tab, we will rebuild this index. And our session ID is 55. And when we execute sp255, we can see that the disk IO column is almost the same as the size of the index. And if we had a bigger index, we could execute sp2 again and again, or executing a query against another DMV, and it would show us the amount of pages that were already processed, and that way we can monitor the progress of the index build. And of course, it's more tricky, and the bigger your index is, it will be less accurate, but it's a way to guesstimate the amount of time you have left in your index tracking. Okay, now after that we've done that, let's talk about batch progress tracking. So we'll close those tabs, and we will open two new tabs about batch progress tracking and a tab with some slow queries. And what we can see here is that we have a few statements, and we will run them. We have a batch with a few statements. And we will run that, and from here we will execute a query against sysdm exec request and SQL text and query plan, and we can see what are we doing. So what we can see here, we have a column called the current batch, which has the whole batch, the statement 1, statement 2, statement 3, and the query itself. And in the running statement column, we see the actual queries that is currently running. We do that by using substring on the text column of sysdm exec SQL text, and we use the statement start offset and statement end offset of sysdm exec request in order to get this specific query. And after this complex math is generated, we call that the running statement column. We also get the execution plan from sysdm exec query plan, and when we push it, it opens it and we get the execution plan, but as we said earlier, we get the execution plan for the whole batch. And if we have a very long batch with a lot of statements, it can be very frustrating to troubleshoot queries. So what we can do is use sysdm exec text query plan, and if you run it again, yeah, my computer is pretty slow today, I apologize. But if we run this statement again, when we hit the query plan column, we can now see that we get the specific statements that it's running and not the whole batch. So this is a very handy tool that you can use if you have very long batches. You can use sysdm exec text query plan in order to see which query is currently running and not deal with the execution plan of the whole batch. Okay, now let's talk about CX packet. And CX packet is maybe the most confusing wait type we have in SQL Server. SQL Server documents and stores information about things that are called wait types. For each and every query that is running, it can wait for a variety of reasons. It can wait because another session blocks it. It can wait because it waits for IO to happen. It can wait because of latches and so on and so on. And one of those wait types is CX packet. So CX packet actually means class exchange packet, and It's called that way because this is the only place where parallel threads exchange packets between them. So it works in the model of a producer and consumer, and in the middle we have a buffer. The producer threads produce packets, they pass it to the buffer, and the consumer threads consume those packets from the buffer. And we have three parallelism iterators. One is distribute streams, taking a single threaded stream and distributing it between parallel threads. Repartition stream, which takes a few parallel streams and redistributes them. And gather streams, which takes parallel information from parallel threads and gets it back to a single thread. So when the consumer thread is the one that is waiting, we will see something that is called e-wait pipe get row. We will see this information in SysDM OS waiting tasks. And this basically means that producer threads don't produce the thread fast enough and push it into the buffer. I will repeat that. When the consumer thread is the one that is waiting, and this will happen most of the times, it means that the producer threads don't produce the packets fast enough. On the other end, when the producer threads are the one that are waiting, we will see in SysDM OS waiting tasks e-wait pipe 0, and this means that the buffer is full. And the consumer thread is not consuming the thread fast enough. Now the issue is the CX packet is usually not a problem. If you search online, you will sometimes see that if you see a lot of CX packet waits, you need to limit the number of threads a query can run with to a single thread. Use option max.1 and so on and so on. And usually this is a very bad advice because CX packet is usually not a problem. The actual problems will be I/O, locks, network, etc. CX packet is not the problem. It's just an indication that there's a problem somewhere else. It's a very, very wise sentence said by Thomas Kaiser. And I will repeat that. CX packet is not a problem. It's just an indication there's a problem somewhere else. So what we will do is query SysDM OS waiting task to get something that is called the node ID. And the node ID that we'll get is the node ID in the execution plan that belongs to the specific parallelism iterator that is currently being processed. And this node ID will be an indication that the subtree under this node ID is currently being processed. And it's very complicated to understand without a demo, so let's do a demo. Okay, we'll take our slow queries again, and we will open another file with a query written by Paul Randall that goes to SysDM OS waiting tasks and gets the information. So we will execute the query again. And execute Paul's query, and let's see what we get. What we see here is we see a few CX packet waits here and here and here and here and here and here, but we also see a page IOLH wait, a few page IOLH waits, and we can see the resource description. And in the resource description, and I will zoom in, we can see e-wait pipe gate row and node ID equals 80. We also see node ID equals 1, but it's not really relevant because this is just the top iterator, and we'll see it in just a few seconds. But the node ID 8 is the one that is interesting to us. So we will click the query plan, and what we can see now is that this parallelism iterator is node ID 1, and this means that the subtree under node ID 1 is currently being processed. But it's not really surprising, right? Because the query is currently running, and node ID 1 is almost the last one that will get the data. But we also saw node ID 8. And node ID 8 is this parallelism iterator. And this means that the subtree under node 88 is the one that is currently running. And now we know that what we're doing right now is reading data, scanning the index of the big transaction history table. And that's what we're doing, and that way we can use CX packet weights in order to understand what our query is currently doing. And just to prove that, if we go back to our query, we can see our page IO latch weights and just take one row, and the resource description here is just a symbol to the page we're currently reading. So we'll go down here, and using DBCC page, we'll be able to see which table we're currently reading, and we need to use AdventureWorks 112. Whoops. Sorry about that. DBCC page. And we will search for the object ID. And the object ID is this one. And when we put it inside the object name function, we can see that this is the big transaction history table, just as we saw in our query plan. So this technique is very useful when you have parallel plans. It's very useful in order to understand what's going on in your queries and which part of your query is currently running. Now let's look at another example. And what we will do, we will begin a transaction and update the big product table to some product ID. And we will do it in transaction, and we will execute the query again. And return to post query. And now we can see that node ID is 3 is the one that is currently being processed. Or to be more exact, node ID, the subtree under node ID 3 is currently being processed. And when we open our execution plan, we can see that node ID 3 is on top of the big product table. And again, this is not very surprising because we blocked the table. And when we look again at SysDM OS waiting tasks, we can see, in addition to our page IO latches, we can see we have a lock on our table. So again, CX packet is not a problem. It's just an indication there's a problem somewhere else. Now, in real life, it may not be that simple. In real life, you will have more complex queries, and let's say view that selects from a view and does a few joins and so on and so on. And what I do a lot of times is I use this method to identify the problematic part of this view or complex query and so on and so on. And I just take this part. It can be a select from a single table or a join between a few tables. And I take this specific part and transferring it into a select into a temporary table in order to help the optimizer generate a better plan. And a lot of times this solves the problem because the most problematic part of the query can now be executed in a more efficient way. And then I can join back from the temp table to the other part of this problematic query, and a lot of times this solves the problem. Okay, and we will roll back here, and our query finished. Okay, Mike, do we have any questions up till now?
Yeah, there's a couple. The first one, the first one's from a bit ago, when you were, excuse me, back when you were doing the profiler. Sorry, I just lost it here. Where'd it go?
No problem.
Yeah, what trace options do you select to see the status on an index build or rebuild? Sorry, when you back then, yeah.
Okay, so so you need to select the event called online index operations. I can't remember the exact name, but let's see. We can see that in a demo. Oops. Yeah, it's called progress report online index operation, and then the most important parts are the SPID and the begin data 1 and the begin data 2. Columns in profiler. In extended events, they have more meaningful names, and they also have the thread ID in extended events.
Okay, thank you. That's okay.
Okay, are there any other questions?
That's okay. That's all for now.
Mike, are there any other questions, or shall we move on?
Yeah, you can move on. Sorry, I thought I had unmuted myself.
Cool. Oh, no problem. Okay, so up till now we talked about parallel plans. What about single-threaded plans where we don't have expected weights? So this is more tricky, but what you can do is you can use a trace flag called query trace on 6849. And this trace flag makes SQL Server run your query in parallel if it can, because you have certain operations that prevent SQL Server from generating parallel plan. But for the most part, you will get a parallel plan, and you'll be able to monitor the progress of the query by using that. Now, this is not supported and not documented, so be careful on where you use it. But if you have a problematic query and you want to understand where the time is going, you can use this trace flag to analyze it. Now, one thing to note here that you need to make sure that the plans look similar, because if we have here we have hash match and hash match, and the plans look pretty much similar. But if, let's say, you have an execution plan, the single-threaded plan do nested loops, and the parallel plan does hash match, then it's oranges and apples. So you need to watch out for that. But if you get the same execution plan, then it's a good indication of where the time goes. And in general, parallelism is a very good performance tuning trick, and you need to embrace it. Okay, now we will move on and we will understand how we identify when SQL Server is performing the sort operation. And this is very important because the sort operation is one of the most expensive operations in SQL Server, because especially if SQL Server has to do it in TempDB. So what I do here is I declare two variables, and I do a select query that selects the product IDs that are between those variables. And the reason I do it is because SQL Server, when he sees variables, he doesn't know the values that are inside the variable. and in those situations, we can get a plan that is not really optimized to the values of those variables. So if we look at the estimated execution plan, we will use Adventure Box 2012 and look at the estimated execution plan of this query. We see that SQL Server thinks that the sort operator will take 32% of the plan. But when I mark the variables and take the actual values, 1001 and 10,001, and hit Control L, we can see that the sort is actually 94% of the plan. And this is where the problem starts, because SQL Server estimated that the sort will be just 32% of the plan, and it will grant it a certain amount of memory in order to perform the sort. Because each and every query that runs in SQL Server has to get a memory grant. And SQL Server allocates the memory grants according to the cost of the plan. And if we measure the cost in a wrong way, we will get problematic memory grants. So now we will run the query. And run pause query again. And let's see what we get. And what we're looking for is something that is called I/O completion. And I/O completion is a weight that we get when SQL Server has to perform some kind of temporary data flashing to disk. And this thing happens in some situations, but in our situation, it happens because we have to sort the data and we don't have enough a big enough memory grant. So we have to spill the data into TempDB. So I/O completion is a good indication that we are currently sorting the data and sorting it specifically in TempDB where the problem happens. Because if we sort it in memory, it's an expensive operation, but it's generally in memory, and memory is generally very fast. But if we do that on disk, it's much slower. So the I/O completion operation can show us that we currently sort the data and can show us that we need to do something about this sort. And in our situation, we will just replace the variables with the constants. Okay, so let's move on. So we talked about CX packet and
One
sorting.
quick question, Matan.
And
Matan? Yeah, one quick question before we so to go back to when you were using the query trace on 8546, how was that really used?
Yeah. Excuse me, can you repeat the question?
The question is, how is that used?
I'm not sure what does how is it used mean, but basically I just need to add that to the end of the select query. And if SQL Server can, it will generate a parallel plan and execute the query in parallel. So again, if we compare those two statements, in this situation, we got we got a parallel plan in the end, the two situations. Basically, when I wrote this script, this statement got a single threaded plan. Let's say we will do option max dot 1. So here we will get a single threaded plan, and Here we get the single-threaded plan at the top, and here we get a parallel plan at the bottom. So I guess my PC got to a situation where SQL Server thinks it will be better to execute this statement in parallel, and we don't need this trace flag at all.
Okay.
But you will get situations where you will get a single-threaded plan, and actually the better way to do it is in parallel, and then you can use this trace flag in order to get the parallel plan and identify what was the problem. And again, please be careful about that because it's not supported by Microsoft.
Okay, thank you. The famous disclaimer.
Okay. Okay, so let's move on. Up till now, it's a very good technique that we learned up till now, but it's kind of cheating, right? Because it's not we have to go into system was waiting task and identify the node ID and so on and so on. And it works. And up to SQL Server 2014, it's basically everything that we had. But starting SQL Server 2014, we have a new DMV that is meant to do this exact thing. It exposes the amount of data and amount of pages and amount of time we've been in each and every operator, and allows us to track the progress of our query. So it monitors real-time query progress while the query is in execution. The counters are per operator, per thread. Data is collected and serialized into the showplan XML when the query finishes. So for the first time, we can use this DMV to actually know how much data has been processed by each and every operator in our query plan. And we can also know, let's say, the optimizer thought that the estimated number of rows for a certain operator were 20, and the actual number of rows is 2 million rows. We can know that in real time and while the query is running, and not only when it finishes, if at all. And let's see a demo of this thing. So we will open our slow queries again, and we will open our query profiles tab again. And we will run our query. And we need to remember, if I now go to the exec query profiles, I don't see anything. What we need to remember to do is when we execute the query, we need to include the actual execution plan. SysDM exec query profile will not show us any information if we don't include the actual execution plan. So we will execute again, or we can use extend events or profiler in order to gather the actual execution plan. But please be careful because it's a very expensive operation to get the actual execution plan. So we will execute again, and now with SysDM exec query profiles, when that returns, we can see that for node ID 10, and I will zoom in, we can see that things starts to go up. If you look at the row count, we can see 3 million. And now 4 million, and when we run it again, 5 million, and so on and so on. And we also have here the query plan, and if we look at node ID 10, we can see that it's an index scan. And if we go down, we can see that node ID 10 is the big transaction history table. And now we can see we don't have to use the parallelism method. We can just see that node ID 10, which is this index scan, is currently being processed. So this is a very, very cool DMV, and we get the data for each operator and for each thread. And we can also aggregate the data. Let's say I don't want to get information for each thread, so I can just aggregate the data and get the information per operator, but not per thread. And what I can also do is, let's say I have a problem where a certain operator, SQL Server estimated a number of rows of X, but the number of rows was actually higher. So I can use this query to see those specific operators and those specific rows and know that there's a problem. Let's say we have a problem in our sort, we can see that using this DMV. This is very, very cool, and if you have SQL Server 2014, you can start playing with it. And now, before we finish, I want to show you one more thing, very, very fresh. We'll soon have SQL Server 2016, actually, and in SQL Server 2016, we have something that is called live query statistics. And Microsoft has already released a few labs that allow us to play with SQL Server 2016. And I will open Management Studio in this file here and go to LQS. This means live query statistics. And I will open this select. Let's connect. And I will drag it here. And we can see here that we have a new button that is called include live query statistics. I hope you see it well. I'm not able to zoom in on this lab, but if we include the live query statistics and execute the query, execute it again, and we can see something that is very interesting. Things are starting to fly between the threads. And I can see for each and every operator how many rows were already processed. You can see actual number of rows 14, and if I go here again, you can see actual number of rows 18, and so on and so on. And I can see how much time an operator has been open. In our case, 30 seconds right now. And this is very, very interesting. And it's built on top of SysDM query profiles, and it will allow us for the first time to track the progress of our query without cheating. Now, it comes with a price. You will have to monitor the actual execution plan. As we saw, we have to include the actual execution plan or include live query statistics or gather it using provider or extended events. But once we do that, it's very, very powerful. Another way I can do that, and you can also see that in the execution query at the bottom left, we can see the progress of our query, 35%, 36%, and so on. And I can also see that if I go to Activity Monitor, and I go to Active Expensive Queries, and right-click Show Live Execution Plan, and I can see the live execution plan of the queries that I've been gathering information on. And one thing that is very interesting here is, let's say I go over the merge join operator here, I can see that if you see the actual number of rows is 109, and the estimated number of rows is something like a gazillion. And even though we only processed 208 rows, it kind of knows that the estimated number of rows is way off, because it shows us that it's 66% done. So I'm not sure how it does it. It's very, very interesting, but again, for the first time, we can monitor our queries with a powerful tool. I would make it better. I would say to Microsoft, tell me which operators are currently being processed by highlighting them in red or something like that. but it's still a very, very good progress. And the other cool thing is that if you have SQL Server 2014, you can use SQL Server 2016 Management Studio and still get this information. You don't have to have SQL Server 2016 in order to see this information. Okay, so with that, I think we will open up for questions, Mike. Do we have any?
There are a couple. Actually, there's one. It's a follow-up to the query trace on. Does that actually force parallelism if it didn't choose it on its own? That's
right.
Okay. That's what it seems.
Right.
Yeah.
Again, if SQL Server can generate a power plan or a power plan, let's say you insert the data into a table variable, it won't generate a parallel plan. I don't know why, but it's one of the parallel plan killers.
I see.
So if SQL Server can generate a parallel plan, it will. Okay.
The last thing, that profile DMV, I'm over here. I'm thinking that's pretty cool looking. That's pretty nifty. Does that change by any? Is that available in all editions of SQL 2014, or do you have to get like Enterprise or something?
I actually didn't check, but I believe it's available in every edition.
Okay, yeah, I'd hope so. It seems like it should be. DMV's got to be pretty much across the board. Yeah. So was that in 2016 or 2014?
The live query UI is in 2016. The query profiles DMV is starting SQL Server 2014. And I forgot to mention that you can play with that in the Microsoft technical labs. And also starting tomorrow, we will have SQL Server 2016 CTP2 on public preview, and we can all download it and play with it.
Right.
So we can wait for tomorrow and start playing with the live query statistics.
So if so Jenna, you just asked when SQL 2012 is going to be released. Tomorrow CTP2 is available, so it's getting closer. So Matan, do you get a feel if they're going to launch 2016 before 2016 actually hits, or are they going to launch it in January or beyond?
From what I hear is that the public preview will be available this summer, but maybe actually CTP2 is considered a public preview, so I don't know. I hope so. I don't really know, but what I do think is that a lot of organizations will skip SQL Server 2014 and wait for 2016 to be out. They will just treat SQL Server 2016 as SQL Server 2014 R2 or something, and we'll wait for that. Right.
Yeah. Okay, and with that, I want to give a hearty thank you, Matan, for your presentation today. That was a lot of stuff that I didn't know was coming in 2014, or is already here. So that's really nice. So with that, we want to wrap up. Any further questions? Let's see. Here's one more that I think looks like it's pretty good. Let's see. So hold on. It's the I can't see the whole question here yet. Hold on. Okay, yeah. Anyway, yeah, so quite a few questions about what's coming in 2016, and that could be a nice topic for our future presentation, and I appreciate that question and that lead-in. We'll consider that and bring that on board to let us know what's going on in 2016. But with that, I want to wrap up today's session, and thank you, Matan, very much for coming out and doing this for us, taking time out from your family later at night there in Israel. Appreciate that very much.
Thanks for having me, Mike. It was a lot of fun.
Appreciate that. With that, I want to do two things. One is I want to announce that we are actually, our next session is June 10th. So please go to dba.sqlpass.org and sign up for that. We'll send you reminders as an email and so forth. And one of the benefits that we have with working with Dell software rather is that we can actually have a little bit of fun as well as be productive here at our virtual chapter is we hand out a door prize. And so today's door prize is a $50 Amazon gift card. And today's winner is Roy Cheng, and we will be sending him his electronic gift card here this afternoon. And with that, I want to thank you all for attending and see you on June 10th. Thank you very much.
Okay. Bye, everyone.